Trigonometric identity. Trigonometric identity, this is when ABC are angles of a triangle. Means what? A plus B plus C equal to pi. So we assume A plus B plus C equal to pi, and then apply this to this result. So first thing, we have to prove that tan A plus tan B plus tan C equal to this one only when A plus B plus C equal to pi. So this solution is of this type. So tan of A plus B, it is because of this condition, so it is pi minus C. Pi minus C, tan of pi minus theta is minus tan C, and tan of A plus B, we are expanding it, and then it is equal to minus tan C, and we are doing cross multiplication, and this gives us this result. In another way also we can do it. We expand tan of A plus B plus C, then this is numerator is tan A plus tan B plus tan C minus tan A tan B tan C, and that is equal to 0. In that way also we can do it. Then this one, sin twice A plus sin twice B plus minus sin twice C. So here we do this. So this is sum converting to product. So it is 2 sin of C plus D by 2, it is A plus B. Sin of C minus D by 2, it is cos of C minus D by 2, it is A minus B. Then this A plus B we write as pi minus C. This is cos A minus B, and this sin twice C, and this is 2 sin C cos C. So this sin C we will take common, and this cos C we write as pi minus A plus B, so that we can apply the formula for cos of A minus B minus cos of A plus A, cos of A plus B. So this is 2 sin C, it is taken common, then this cos of A minus B, and this is cos of pi minus theta is minus cos theta, so it is plus 2 cos of A plus B. Then it is again this formula cos C plus cos D, and this cos C plus cos D gives us the 2 cos A cos B. So result is this 4 cos A cos B sin C. And cos of twice A plus twice cos twice B. So this is also same procedure. So cos twice A plus cos twice B. So cos C plus cos D formula, it is 2 cos of A plus B cos of A minus B. Then cos twice C, because here this is this here we need this minus 1, so we write this as 2 cos square C minus 1. Then it is A plus B we write as pi minus C, and this is 2 cos C cos of C we write as pi minus A plus B, and this cos C will take common. So this is minus cos of pi minus theta is minus cos theta, so minus 2 cos C. Then this is cos of A minus B, this is again cos of pi minus theta is minus cos of A plus B, and this is minus 1, and cos 2 cos C is taken common, then it is cos A plus B plus cos A minus B, again cos C plus cos D formula, we are getting 2 cos A cos B. Answer is this, it is right hand side. Next one is this one, cos A plus cos B plus cos C. So cos C plus cos D is 2 cos of C plus D by 2 cos of C minus D by 2, and in right hand side it is 1, so this cos C we write as 1 minus 2 sin square C by 2. It is now A plus B by 2, so A by 2 plus B by 2, so this we write as pi by 2 minus C by 2, because A plus B plus C is pi. So 2 cos of pi by 2 minus C by 2, this is cos of A minus B by 2, and this 2 sin square C by 2 we write as 1 as sin C by 2, it is kept like this, and it is pi by 2 minus A plus B by 2. Then this becomes sin, so it is 2 sin C by 2, this is 2 sin C by 2, it is taken common, then it is cos A minus B by 2, and this is sin of pi by 2 minus theta is cos, so cos of A plus B by 2. So it comes as this, and it is cos C minus cos D again, and it is so 2 sin of C minus D, D minus C by 2, and sin of C plus D by 2. So this one, so we get this one. Next, sin square A plus sin square B plus sin square C. So this we write as 2 sine square a. 2 sine square a we write as 1 minus cos twice a. So we get this one, cos twice a plus cos twice b. This is sine square c. Sine square c is taken as it is, and it is again it is cos c plus cos d. So cos a plus b, cos c plus cos d, it is 2 cos of c plus d by 2 into cos of c minus d by 2, and this half goes cancels. Then it is 1 minus this one. Then this sine square c we write as 1 minus cos square c. So this a plus b, it is again pi minus c, then cos c, then this c cos c we write as pi minus a plus b. Then it is 2 plus cos c, this is cos of pi minus c is minus cos theta. So 2 plus cos c, this is cos of a minus b, this is again cos of pi minus theta is minus cos theta, and this is plus, so it is cos c. Then it is 2 plus cos c is taken common, it is cos a minus b plus cos a plus b, and this is the formula to cos a cos b. Next, this is for a plus b plus c equal to 0. A plus b plus c equal to 0. So this is cos c plus cos d, this 2 cos of c plus d by 2 cos of c minus d by 2. Then right hand side is minus 1, so we write it as 2 cos square c by 2 minus 1. Now because this is equal to 0, so a plus b is minus c. So this is minus c by 2, this is cos a minus b by 2, this is 2 cos c by 2 minus 1, cos square c by 2 minus 1. Then this cos of minus theta is cos theta, so it is 2 cos c by 2. Then it is cos of a minus b by 2, 2 cos c by 2, and this again we write as minus a plus b by 2. Then minus 1, then cos c by 2 it is taken common, it is again cos of a minus b by 2 plus cos of, this is cos of minus theta is cos theta. And then it is again cos c plus cos d. Its formula is 2 cos of c plus b by 2 cos of c minus d by 2. This gives us cos a by 2 cos b by 2. So it is 4 cos a by 2 cos b by 2 cos c by 2. This is minus 1, and we get the right hand side. Then this one is cos a cos b cos c, 10a plus 10b plus 10c, this one. So this one cos a, left hand side is cos a cos b cos c, 10a plus 10b plus 10c. This we get from this, cos of a plus b plus c equal to 0. 10 of 0 is 0, so this is equal to 0. The expansion for a 10 of a plus b plus c is this one, and this equal to 0 means numerator is 0, so 10a plus 10b plus 10c is 10a 10b 10c. We are applying this, and then we have sin a sin b sin c. Then this is for a plus b equal to c, it is sin square a plus sin square b plus sin square c. Then it is we write as again 2 sin square a as 1 minus cos twice a, 2 sin square b as 1 minus cos twice b. This is sin square c. This sin square c we write as 1 minus cos square c, because in right hand side it is no negative, so we write 1 minus cos square c. So 1 plus 1, this gives us 2, then 2 minus, this is cos a plus b. So in place of a plus b we are writing this one, cos a plus b is c, cos c. Then it is cos of a minus b, and this one it is this minus cos square c. So this is 1 cos c is coming out here, and this other cos c we write as a plus b, c as a plus b. So it is again cos of a minus b plus cos of a plus b, and so it is 2 minus 2 cos a. So this sum is 2 cos a cos b. So we are getting this one. Next this one, b minus a plus c, c minus a plus b. So this we do as b minus a plus a plus b. Sign of left hand side is b minus a plus b, because c is equal to a plus b. So this c is equal to a plus b, and this is equal to c is equal to a plus b means this is 0. So it is sin twice a plus sin twice b. So 2 sin of a plus, so sin c plus sin d, so 2 sin of c plus d by 2 cos of c minus d by 2. We are getting this as 2 sin c, then it is cos of a minus b, we are expanding it, and then we get this result. Then these are exercise a plus b plus c equal to pi. So this one we can do as cot a cot b plus cot b cot c plus cot c cot a equal. So we have got a plus b plus c equal to pi. So tan of a plus b plus c equal to 0. A plus b plus c equal to 0. So it is tan pi is 0. Implies we have got earlier tan a plus tan b plus tan c equal to we get is product tan a tan b tan c, and what we do, we divide by right hand side. So right hand side is 1, then we have tan a plus tan b plus tan c divided by tan a tan b tan c, and right hand side is equal to 1. So tan a by tan a tan b tan c, it is cot b cot c. So we now have first term is cot b cot c, next term is cot a cot c or cot c cot a, and third term is cot a cot b, cot a cot b, cot a cot b. This is equal to 1. Then sin twice a plus sin twice b plus sin twice c. 4 sin a sin b sin c. So we so sin twice a plus sin twice b. So number 2 left hand side is 2 sin c plus sin d, it is sin of a plus b by 2 twice a plus twice b by 2, then cos of a minus b by 2 twice a minus twice b by 2, it is a minus b, and sin c we write as 2 sin c cos c, sin c cos c. Then sin of a plus b we write as 2 sin of pi minus c, pi minus c. Then cos of a minus b, cos of a minus b, then 2 sin c plus 2 sin c, and cos c we write as plus cos c, cos c we write as cos of pi minus a plus b, a plus b. So cos sin of pi minus theta is 2 sin sin of pi minus c is sin c, so it is 2 sin c, 2 sin c, this is 2 sin c, this is also 2 sin c, we are taken common, then it is cos of, first term it is cos of a minus b, and second term cos of pi minus theta is minus cos theta, so it is minus cos of a plus b. So cos c minus cos d, it is 2 cos of c d minus c by 2 and into sin of c plus d by 2. So we have this, applying this one we get 2 sin a sin b. So this is the right hand side. Then next one, this is half diagonal. So it is number 3. Left hand side it is sin a plus sin b, it is 2 sin of a plus b by 2 cos of a minus b by 2. Sin c we write as plus 2 sin c by 2 cos c by 2, and then this sin of a plus b by 2 we write as 2 sin of pi by 2 minus c by 2, then cos of a minus b by 2, then this will be cos c by 2, so this will be cos c by 2, this is cos c by 2, so we write this 2 cos c by 2, and this sin c by 2 write as sin of pi by 2 minus a plus b by 2, so this is 2 cos c by 2, so we are taking common 2 cos c by 2, then it is cos of a minus b by 2 plus cos of a plus b by 2, so this is cos c plus cos d, it is 2 cos of c plus d by 2 cos of c minus d by 2, so this gives us 2 cos c by 2, and this gives us 2 cos a by 2 cos b by 2, so answer is 4 cos a by 2 cos b by 2 cos c by 2, so it is right hand side. So this is the way. Then next one is cos square a plus cos square b plus cos square c, so that we have done earlier, sin square a plus sin square b plus sin square c, so this we write as 2 cos square a, so 2 cos square a we write as 1 plus cos twice a, then cos twice a plus cos twice b, we will apply cos c plus cos d formula. So 4 is half of left hand side is half of, so we write as 2 cos square a plus 2 cos square b, and cos square c we keep this as it is, cos square c, then this one half, then 2 cos square a we write as 1 plus cos twice a, so it is 1 plus cos twice a plus 1 plus cos twice b plus cos square c, then half plus half, it is 1 plus 1 is 2, and 2 by 2 it is 1, so constant term we get is 1, then plus half of, so cos c plus cos d is 2 cos of a plus b cos of a minus b plus cos square c, so half and 2 goes, so this is equal to 1 plus, so cos of a plus b we write as cos of pi minus c, then cos of a minus b, and this cos square c we write as 1 c we write as cos c, and other c we write as cos of pi minus a plus b. Then cos of pi minus c is minus cos c, so this is equal to 1 minus cos c, then cos of a minus b plus cos c, then this is cos of pi minus theta is minus cos theta, so this sign is minus, it is cos c, then cos of a plus b, then 1 minus cos c we take common, 1 minus cos c we take it common, this is cos of a minus b plus cos of a plus b. Here one thing you see, we are writing here cos left hand side. Actually this is not left hand side, you write it as not left hand side, we write it as cos square a, we write it as cos square a plus cos square b plus cos square c is equal to this, not left hand side, because in left hand side this term is also there. And after simplification we are getting it as 1 minus cos c, then it is cos c plus cos d, it is 2 cos of c plus d by 2, so it is cos 2 cos of a plus b plus a minus b by 2, it is cos a. So what we get, it is cos c then into 2 cos a cos b, 2 cos a cos b. So what we are having, cos this cos square a plus cos square b plus cos square c is equal to this one. So this implies, now you write, so now this implies you take this term to left hand side, so we get cos square a plus cos square b plus cos square c plus 2 cos a cos b cos c is equal to 1. Proved. So this is the way to prove it. Next is this one, tan a by 2 tan b by 2. So how will you do it? This one, tan of we expand tan of a plus b plus a by 2 plus b by 2 plus c by 2, and because it is pi by 2, so we get the denominator 0. So here we will write it. Number 5, tan of a by 2 plus b by 2 plus c by 2 is equal to, this is numerator is, so expand tan a by 2 plus tan b by 2 plus tan c by 2 minus tan a by 2 tan b by 2 tan c by 2 divided by 1 minus tan a by 2 tan b by 2 minus tan b by 2 tan c by 2 minus tan c by 2 tan a by 2. So this is the expansion for this one, and because it is pi by 2, because a plus b plus c is pi, so this is pi by 2, so this means this is equal to infinity, so this means, this implies denominator is 0, denominator is 0. So denominator is 0 means this is equal to, so we have this one, then this number 6. I think you can try this and you can do it. Next one, a plus b plus c is pi by 2. This is also like this. So tan of a plus b plus c will be, so in place of this we write a plus b plus c, so this will be a b c. So we will have tan a by tan a tan b plus tan b tan c plus tan c tan a is equal to 1, and then we divide. So in like this, what you can write here, number 2 1. So this implies, because tan of a plus b plus c equal to pi by 2, tan pi by 2 is 1. So this implies tan A tan B plus tan B tan C plus tan C tan A is equal to 1. Then we divide by tan A tan B tan C, both side. So this implies this is tan A tan B plus left hand side is tan B tan C plus tan C tan A. This is left hand side. We are dividing by tan A tan B tan C. Tan A tan B tan C, and at the same time we have to divide the right hand side also. So right hand side is 1. It is tan A tan B tan C. So what we are having, left hand side is cot A, this is cot B, this is cot C, this is first term is cot C, second term is cot A, third term is cot B, and right hand side is cot A cot B cot C. We are having this one, tan A tan B plus tan C. So this also same thing, this is equal to 1. We have already got it from this expansion formula. This you will try it like 2 sin square A, you write as 1 minus cos twice A, like this we can do it. So in place of this we need to write, it will be 2 sin square A, then 2 sin square will be 1 minus cos twice A, or 1 like this. Then A plus B plus C equal to pi, then prove it. So it will be this is also not tough, so you can do it. Next is inverse circular function. So inverse circular function is inverse circular function, it is sin theta is equal to x, then theta is sin inverse x. So sin inverse half. So in this we see sin inverse half will have many values for this, but we write only the principal value. So sin inverse minus half, we write minus pi by 6. So actually this is like this. So this is the wave, sin x is wave function, sin x, it is wave, it is like this, it is like this. Here also this is this. Now we consider this part only, this part for sine function we consider this part. So this is minus pi by 2, this is pi by 2. For minus pi by 2 this is minus 1, and for plus pi by 2 it is 1. This is sine curve. So when y is here, this is x axis, this is y axis. So when here it is minus 1 to 1, so x varies from this, x will be in this region, so x is in between. So we can consider the values, this minus pi by 2 to pi by 2. So when we say sin theta is equal to minus half, we say the negative values when minus half. So here this is 1 minus 1, this is minus half, so we consider this part. So x will be minus of x is minus of pi by 6. So theta is minus pi by 6. This is for sine curve. If we consider cosine curve, then cosine curve is, this is cosine curve is like this. This is 1, 0, this. So this is 1, this is -1, this is 0, here this part is, this is 0, this is pi. Cos pi by 2 is 0. So cosine function is like this. So when we write principal value, then suppose we are having cos theta is equal to -half. Then we consider this point, means pi by 2 in the second quadrant. So theta will write as, theta will be pi minus pi by 3. Cos of pi minus theta is minus cos theta. So cos of pi by 3 is half. So cos of pi minus pi by 3. So we consider this one, pi minus pi by 3, this value. So in this way we write that these are the principal values. So when we say cos inverse minus half, we write it as pi minus pi by 3. Similarly, in case of tan also we consider in between positive this, because tangent curve is this, tangent curve is like this. So this is pi by 2, this is minus pi by 2, this goes to infinity here. So we consider this is the fourth quadrant, this is the first quadrant. For sine also we consider fourth quadrant and first quadrant, but only for cosine we consider first quadrant and this is second quadrant. So this is the way to write inverse values. Next, so these are the relation. Sin theta is x, then cos theta is this. So theta is sin inverse x. Same theta is for cosine measure, this cos inverse this tan inverse, this one cot inverse. So these are the relations. From this we derive all this. Cosec theta is 1 by x, so theta is cosec inverse 1 by x. Then sin inverse x plus cos inverse x is pi by 2, because sin theta is cos of pi by 2 minus theta, so cos inverse x is pi by 2 minus theta, so add it, we get pi by 2. Similarly, sec inverse x, it is cosec from this relation, cosec pi by 2 minus theta is sec theta, so we get sec inverse x plus cosec inverse x is pi by 2. Then tan inverse x plus cot inverse x is pi by 2. Also we have tan inverse x as 1 by cot inverse of 1 by x, then that is also one reason. This reason, sin inverse, no, here. So as we have got sin inverse x is equal to cosec inverse 1 by x, because sin inverse x is equal to theta implies sin theta is equal to x, then cosec theta will be 1 by x. So tan inverse x is equal to theta implies tan theta is equal to x implies cot theta is equal to 1 by x, 1 by tan theta. So cot inverse 1 by x is theta. So what we can write, tan inverse x is equal to cot inverse 1 by x. So tan inverse, so this is, there are two relations. So tan inverse x plus cot inverse x is pi by 2. At the same time, tan inverse x we can write as cot inverse 1 by x. Now to prove this, tan inverse x plus tan inverse y, it is assume tan inverse x is alpha, then tan alpha is x, that we are applying this addition formula. So tan alpha plus tan beta, it is 1 minus tan alpha tan beta. This is x plus y, because it is x, this is y. So x plus y by 1 minus xy, then alpha plus beta is tan inverse of x plus y by 1 minus xy, and it is alpha we are writing tan inverse x, beta we are writing tan inverse y, and we are proving this. Similarly for this addition also, because alpha plus beta plus gamma, we have this expansion. So in place of tan alpha we write x, tan beta is y, tan gamma is z, and then alpha plus beta plus gamma we write tan inverse x plus tan inverse y plus tan inverse x, we get this one. Then this is also addition formula, sin inverse x plus sin inverse y. So sin of alpha plus beta, this is sin alpha cos beta, cos alpha sin beta. So sin alpha is x, then cos beta is root over 1 minus y square. So sin alpha plus beta is sin inverse of this. So alpha plus beta is sin inverse of this value. Then if it is alpha minus beta, then it is this will be minus. Sin alpha cos beta minus cos alpha sin beta, it will be minus this one. So sin of alpha minus beta is this. Then similarly cos inverse x plus minus cos inverse y, same formula, addition formula. So cos of alpha plus beta is this, then alpha plus beta is cos inverse of this value, then alpha minus beta is cos inverse of this value, it is plus, so it is minus plus. Then 3 sin inverse x is equal to this. So again it is multiple angle, so sin of thrice alpha, so sin of thrice alpha is this value, sin of thrice alpha we have got earlier. So 3 sin alpha minus 4 cos sin cube alpha, in place of sin alpha we write x, in place of this we write x cube, so it is sin inverse of 3x minus 4x cube. Similarly this is also cos inverse, cos of thrice alpha we write as 4 cos cube alpha minus 3 cos alpha. Then same procedure, tan thrice alpha is this one, we are replacing this tan alpha as x, is x cube, so 3 tan inverse x, it is this value. Then tan inverse x, so here tan inverse x, tan alpha is equal to x, then we write sec alpha. Sec alpha is root over 1 plus tan square alpha, this is 1 plus x square, so it is alpha is equal to sec inverse of this. So first we are having tan inverse x as alpha, and then we get alpha as sec inverse of this, so they are equal. Then 2 tan inverse of this value, so 2 tan inverse of this value, so we write tan inverse, so 2 tan inverse alpha, 2 tan inverse x, so 2 tan inverse x is this one, 2 into x, this is x, by 1 minus x square. So after simplification we get this value, minus 1 minus x square by twice x, this is after simplification. And then sin inverse, we convert it to tan inverse. Sin inverse this value we write in terms of tan inverse, so sin inverse this we are getting as tan beta, so sin beta, so beta is tan inverse of 1 minus x square by this. So tan twice alpha plus tan twice beta, so this we are writing as alpha, this as beta, so tan twice alpha plus tan twice beta, so tan twice alpha plus tan twice beta by 1 minus tan twice alpha tan beta. Then this tan twice alpha, this one tan twice alpha is this value, and tan beta is this value, so this we get tan, and this we applying this formula, and ultimately we get this as 0, and this 0 means tan pi. we will write 10 pi, not 10 0, because it is sum of some values. So we write this as, because these are some values, we consider we don't consider this as positive and negative, so we consider this as some positive values, so it is equal to pi. Then sine inverse half. So sine inverse x plus cos inverse x, we have got it, it is pi by 2. So sine inverse half we write as or we can write the values also. Sine inverse half is pi by 3 and this is pi by 6, so sum is pi by 2. Then tan inverse x, that we have got tan inverse x plus tan inverse y, so this also number 2 we do tan inverse x is equal to alpha, and tan inverse y is equal to beta, we are assuming it. Then this implies x is equal to tan alpha, this implies y is equal to tan beta. So this is alpha minus beta, this is tan inverse, so we write tan of alpha minus beta. Tan of alpha minus beta is tan alpha minus tan beta, so tan alpha is x, tan beta is y, then 1 plus tan alpha tan beta xy. So alpha minus beta is tan inverse of x minus y, so in place of alpha we write tan inverse x, this is tan inverse y, so we have this. Similar this one, sine of twice x, so this is alpha, so sine inverse x is alpha, this is sine, so what we have, sine of twice alpha is equal to 2 sine alpha cos alpha, 2 sine alpha cos alpha, so this is equal to 2 sine alpha is x and cos alpha will be root over 1 minus x square, 1 minus x square, so this value is here. So twice alpha is sine inverse of this, so 2 into alpha is sine inverse x, it is so this one is in same way. Then tan inverse x, this one, so tan inverse x minus y by 1 plus xy, this value, so in place of this we write tan inverse x minus tan inverse y, in place of this we write tan inverse y minus tan inverse z, and this one is tan inverse z minus tan inverse x, and sum is 0. Then this one 2 tan inverse x, so 2 tan inverse x is, this is so we write tan inverse x is equal to alpha, this is number 6, so x is equal to tan alpha, x is equal to tan alpha. Then tan of twice alpha will be 2 tan alpha, tan of twice alpha will be 2 tan alpha by 1 minus tan square alpha. So first part is, this implies twice alpha is equal to tan inverse of 2x by 1 minus x square. This is the first part. This is for second part. This we need sine of, we have to find sine of twice alpha. So sine of twice alpha is, sine of twice alpha is, in terms of tan value it is 2 tan alpha by, we have got it, 1 plus tan square alpha. So this is equal to twice x by 1 plus x square. So twice alpha is sine inverse of twice x by 1 plus x square. Similarly cos twice alpha is 1 minus tan square alpha by 1 plus tan square alpha, and we get it. Then sine inverse x plus sine inverse y plus sine inverse z equal to pi. So if sine inverse x is A, sine inverse y is B, sine inverse z is C, these are some angles, so A plus B plus C equal to pi, we can have it like that. So if A plus B plus C equal to pi, then this is x into x, so sine A cos A, sine, this is sine A cos A, this is sin b cos b, this is sin c cos c. This is 2 sin a sin b sin c, sin a x. So what do we need to do? A plus b plus c equal to pi, a plus b plus c equal to pi. Then this is x is sin a, root over 1 minus x square is cos a, root over 1 minus x square is cos a. So x into root over 1 minus x square, it is 2, it is sin a cos a. We can write half of sin a cos a, half of, sorry, sin a cos a is half into 2, this one. So this is equal to, so the first part it is half of sin twice a. Then second part is half of sin twice b, and third part is half of sin twice c. So a proved earlier, a plus b plus c equal to pi. This implies sin twice a plus sin twice b plus sin twice c is equal to 4 sin a sin b sin c. So we apply this one. So therefore we try from left hand side. We try from left hand side. So left hand side is half of sin twice a plus sin twice b plus sin twice c. Then again we do it sin twice a as sin twice a plus sin twice b as. So after writing this, we start from this. So that we have done earlier for identities. We start from this one. So this is equal to, so left hand side is half of sin twice a plus sin twice b plus sin twice c. Then sin twice a plus sin twice b we do as this sin c plus sin d formula. This is sin twice c. So you proceed it and we'll go get it. Then this is cos of 2 sin inverse x. So 2 sin inverse x, it is cos of twice alpha, you can write. So number 8 it is, so sin inverse x is equal to alpha, then x is equal to sin alpha, then cos of twice alpha is 1 minus 2 sin square alpha. This is equal to 1 minus 2x square. So twice alpha is, this implies twice alpha is cos inverse of 1 minus 2x square, and twice alpha is 2 sin inverse x. So 2, so cos of twice alpha, cos of twice alpha, so cos of 2 sin inverse x, it is 1 minus x square. This is this value. Similarly this one also, sin of cos inverse x. So cos inverse x we write as alpha, then cos alpha is equal to sin of alpha will be, so how will you do it? Cos sin of alpha so cos inverse x is equal to alpha. This implies sin alpha is equal to, x is equal to cos alpha, x is equal to cos alpha, then x is equal to cos alpha, then sin alpha will be root over 1 minus x square. 1 minus x square. So what we get, sin of alpha is equal to root over 1 minus x square, and sin inverse x. So sin of cos inverse x is equal to, or what you can do, sin of cos inverse x. So cos inverse x we write in terms of sin inverse x. So sin of sin inverse root over 1 minus x square. So this is equal to root over 1 minus x square. So sin of sin inverse, this, it is this, and sin inverse x, it is, if it is alpha, then we can do it again in terms of cosine. We can write it as, so it is cos of cos inverse, cos equal to cos of cos inverse root over 1 minus x square, and this one we write as cos of, this is sin inverse of x, sin inverse of root over 1 minus x square whole square. So it is again x. Then this is tan inverse x minus tan inverse y. This is tan inverse x minus y by 1 plus xy. Then we convert it to cos inverse x, that we have done earlier, because every inverse measures we can write as this. So this is cot inverse y, you can write it as tan inverse 1 by y. So tan inverse x plus tan inverse y, we know the formula. This is also same. So these are the solve cot inverse x plus, so this is for solution, cot inverse x plus tan inverse x is equal to pi by 2. Cot inverse x, it is tan inverse 1 by x, then we add it just as this. So number 1, tan inverse 1 by x plus tan inverse 3 is equal to pi by 2, and we add it, it is tan inverse of 1 plus x plus 3 by 1 minus 1 by x into 3. So this is infinity, because it is pi by 2, so this should be infinity. So this implies 1 equal to 3 by x. This is 0, denominator is 0, implies x is equal to 3. So these are the way to solve this. Then this is properties of triangle. Properties of triangle ABCR. So here actually this is a triangle. We say this is A, B, C. This we name as C, small c. This is name as A side. This is name as B. So these are the relations. A by sin A. This is sine rule. This is cosine rule. This is tan rule. So these are the proof. These are the proofs. A is equal to B cos C plus C cos B. So because this is given sine rule, so this is K, we are replacing this, so it is sine of B plus C formula. So sine of b plus c, so k sine b we can write as small b out of because of this. Then sine of a by 2, sine of a by 2, it is 1 minus 2 sine square a by 2. Then this is 1 minus cos a, so b square plus c square minus a square by 2. And after simplification we get this a plus b plus c as twice as perimeter of this, so it is s minus b s minus c. And sine of a by 2, this is s minus b by s minus c, it is this one. Cos is this. So these are the calculations. Cos a is, we are writing this as this, it is twice a plus b plus c into this, then root over, so this value. Then area of triangle, it is bc sine a by 2. Area of a triangle is half bc sine a, it is because bc, so this is the triangle, this is a, this is b, a b c, a b c, so this is b, this is c. So if we consider base as this b or base as c, so we consider say base is b, then this is the b is the base, or better we write this one like this. B, we consider b as the base, so this is b, this is b means this is b, so a b c, this is c. So b is the base, altitude will be this one, so this is angle a, this is angle a, so c sine b, sorry c sine a, c sine a is this altitude, so this is c sine a, so this is the altitude, this is altitude, this is altitude, this is base half, so bc, so sine a we write as 2 sine a by 2 cos a by 2, half will go, so sine a by 2 we write this one, this is sine a by 2, this is sine b by 2, or this formula. Then this is proof of this, so we replace b as k sine b, k sine c, k sine b, k sine c, then sine b minus sine c, formula product, it is transformed into product, this is product, product is 2 cos b plus c by 2 sine b minus c by 2, this product is 2 sine b plus c by 2 cos b minus c by 2, and we get this as cot, this is tan, and have this. Then this is also a square minus b square minus c square tan a. So to prove it, this is cosine rule, a square minus b square minus c square, this is cosine rule. Cosine rule is b square plus c square minus a square, it is twice bc cos a, so it is minus twice bc cos a into tan a, then cos a, it is sine a by cos a, so cos a will go, so it will be minus twice bc sine a, so this is twice bc sine a. Then this is area of triangle, area of triangle, this is 0. This one is a sine a minus b sine b, we apply this sine rule, k sine a in place of a we write k sine a, so sine a into sine a, this is sine b into sine c, so sine square a minus sine square b, this formula is sine of a plus b into sine of a minus b, this is trigonometric formula. Then in place of a plus b we write pi minus c, this is k sine c again, k sine c in place of k sine c we write this c sine of a minus b, so it is c sine of a minus b. Then this one a cos a, so in place of a we write twice our sine a, cos a, So 2 sin a cos a means sin twice a, sin twice b sin twice a, because this is an identity, because ABC are angles of triangle. So we have got earlier, this is 4 sin a sin b sin c. This is the right hand side. Then this is also another thing. C, in place of c we write k sin c. So sin c we write as 2 sin c by 2 cos c by 2. This c by 2, it is pi by 2 minus a plus b by 2 cos a minus b by 2. So this one. Next one. So these are very simple thing. Most of the things we are applying the sine rules and cosine rules. This is a sine, so this a we replace by sine a, this number 1. So a is left hand side is sine of k we write here k sine a sine b minus c. So this a we write as k sine of pi minus b plus c. Means what? This left hand side will be, so left hand side will be k, then sine of pi minus theta is again, this is sine theta, so it will be k sine b plus c sine b minus c. So this part will be this one, and this is sine square b minus sine square c. Similarly, this one is k into sine square c minus sine square a. This is k into sine square a minus sine square b, and summation is 0. This is also, this is a is sine a, k sine a. So k sine a sine b. This is, so it is sine a sine b minus sine c sine a. This is sine b sine c minus sine a sine b. This is sin c sin a minus sin b sin c. So sum will be 0. This we have done it. So these are the problems. Okay. So trigonometry is finished here.